So welcome to the video. Today we're going to take a look at how to do a Friedman test on version 29 of SPSS. So this is the non-parametric equivalent of the within participants one-way ANOVA. So we can use this test when we have a categorical independent variable and when we have a dependent variable that is continuous or ordinal. So that's one of the things that distinguishes this test from the within participants ANOVA, is that we can do it with ordinal data, not just continuous data. Also, this test doesn't make any assumptions about normality like the within participants ANOVA does. So for this example, let's imagine that we're looking at how hungry people are in the morning, in the afternoon, and the evening. So these scores here represent the level of appetite that participants have. So let's imagine that they had to choose a score between 1 and 10 based on how much appetite they had, and they repeated that question in the morning, the afternoon, and the evening. So let's take a look at how to put these data into SPSS. We can go down to variable view at the bottom, so we'll click on that, and then we're just going to tell SPSS what the different levels of the independent variable are. So I've gone to the top cell in the name column, and I'm going to write morning. And then in the cell below that, I'll write afternoon, and then in the cell below that, I'll write evening. So I'm just going to use this measures column here to tell SPSS that we have scale data, which is just another word for continuous data. But as I mentioned before, we can actually use this test if we have ordinal data. So once I've done that, I'm going to go down to the bottom of the screen and click on data view. And we can see that morning, afternoon, and evening appear at the top of these three columns. So I'm going to go back to my Excel file and I'm going to copy all of the data. So just select it, then press Command or Control C, and then go back to your SPSS file and then click the top left cell and then press Command or Control V to paste that data in. And then we're ready to run the analysis. So we can go up to Analyze and we can go down to Non-Parametric Tests, then to Legacy Dialogues, and then to K-Related Samples. We can then just transfer all of the levels of our independent variable across to the test variables box. We can see that Friedman is already selected here. And if we go to this statistics button, if we click on that, and then we can choose quartiles, and then go to continue, and that's going to ensure that we have medians for each of these levels of the independent variable in our output. So we'll just go to OK. And if we look at this descriptive statistics table, we can see that the median appetite score in the morning was 4, and then we have median scores of 6 in both the afternoon and the evening. And if we look at this test statistics table, we can see that the value in the async row is 0.001. As this is less than 0.05, it indicates that there's a significant effect of time of day on appetite. Something this doesn't tell us is whether morning differs significantly from afternoon, whether morning differs significantly from evening, or whether afternoon differs significantly from evening. And so to investigate that, we have to use some follow-up tests. So we can actually complete some Wilcoxon signed ranked tests, which are the non-parametric equivalent of the paired samples t-test. So to run these, let's go up to Analyze, and then down to non-parametric tests again, then again to legacy dialogues, and this time we'll go to 2 related samples instead of K related samples. And here we're going to transfer one level of our independent variable across to here using this arrow, and then we'll transfer another level so that it's next to it, and then we'll go back to the first level, and then we'll go to the last level. So we've got morning, afternoon, morning versus evening, so now we just need to do afternoon versus evening. And we can see that we've got the Wilcoxon test selected already here. So let's just go to OK, and that's going to run those tests for us. So we can see now that we have 3 p-values representing comparisons between each of the levels of the independent variable. So we can see that afternoon versus morning, we have this value here, less than 0.05, so significant difference between the afternoon and the morning. Evening and morning, again less than 0.05, so another significant difference. And over here, this value is above 0.05, so we do not have a significant difference in appetites between the evening and the afternoon. So that's essentially how you run the test, but let's take a look at how you can write up these results. So we've started off by saying a Friedman test revealed a significant effect of time of day on appetite scores, and then we've inserted some statistics into the end of that sentence. So let's take a look at where those statistics come from. So I've gone back up towards the top of my SPSS output file, and I can see chi-squared in the example results equals 18.62. So that's coming from this chi-squared row in the test statistics table, 18.62. In parentheses here I have 2. That is corresponding to the value in this degrees of freedom row of the test statistics table. And I have n equals 20, which is just the number of participants that I have. Finally, we have this p-value, so p equals less than 0.001, and that again comes from this test statistics table, and this bottom row we can see that the value is less than 0.001. So that's how you report the results of the Friedman test, but let's also take a look at how we can report the results of the Wilcoxon signed ranked tests. So we've said Wilcoxon signed ranked tests indicated that appetite scores were significantly higher in the afternoon compared to the morning, and significantly higher in the evening compared to the morning. However, there was not a significant difference between the evening and afternoon. So in each case I've reported the median every time I've referred to a level of the independent variable. So here I've referred to the afternoon, and then I've reported median equals 6. So that just comes from this descriptive statistics table and this percentiles 50th median column. So there's the afternoon, there's the 6. And then I've just done that every time that I've referred to a different level of the independent variable. So there's the median for morning, and there's the median for the evening. And every time I've made a comparison, I've reported a z value and a p-value. So here we're comparing the afternoon and the morning. So we need to find the statistics that correspond to the morning and the afternoon. So we can see those here in this test statistics table. So we've got the z value here, minus 3.50. That's what I've reported here. And we've got this p-value, p equals less than 0.001, and that's what I've reported here. And then I've just done the same thing for when I've compared the evening and the morning, and when I've compared the evening and the afternoon. You'll notice as well that I've also reported R values every time I've made a comparison. SPSS doesn't actually provide us with these values, so we have to generate these ourselves. So the R values are effect size values, and they're quite easy to generate. You just need to divide the Z value that you have for a particular Wilcoxon test by the square root of the number of observations within that test. So I've just taken this Z value. So I've got these sort of formulas here. So one of my Z values is 3.5, and I'm saying I need to divide that by the square root of the number of observations. So if you remember, we have 20 participants, and each Wilcoxon test is looking at 20 participants in the morning and those same participants in the afternoon, or in the morning and in the evening, or in the afternoon and in the evening. So each time we have 40 observations. So this is the formula here. So 3.5 is the Z value divided by the square root of 40. And probably the easiest way to calculate the value is just to go to Google. So I've copied and pasted these values into Google, and I will see what it says. So it's telling me 0.55. So that corresponds to what I've written here. So the R value equals 0.55. And then I've just done the same thing for every time I've made a comparison. So there's another R value here, and there's another R value here. And each time I'm referring to one of those R values, I'm saying it's either small or moderate, and sometimes you can use large. So I'm making those descriptions on the basis of what Cohen said in 1988. So he said an R value above 0.1 can be described as small, an R value above 0.3 can be described as moderate, and an R value above 5 can be described as large. So for example, if we look at this value here, it's 0.25, so it's above 0.1, but it's below 0.3, so I'm describing that as small. So that's essentially how you report the results, but let's take a quick look at how to visually represent these results as well. So to create a graph for these data, we can go up to graphs, then down to charts builder. We're just going to ignore this dialog box, so we'll just click OK. And then we've got bar selected here, and then I'm just going to drag this simple bar option up into this window. Then I'm going to transfer one of my levels of my independent variable to the y-axis, and then I'll transfer the second level to the same bits. That opens this dialog box, but we can just close that by going to OK, and then we'll transfer the last of the levels of the independent variable to this same box. And now we have 3 bars representing the 3 different levels. And one thing we want to change is that we don't want the bars to represent mean scores, because it's more common with parametric tests to use the median. So we're going to change what it says over here so that we're going to get the median. So we'll go to the statistic bits and then select median. So morning is median, and then we just do the same thing for the other levels of the independent variable. So afternoon is median, and evening is going to be median as well. So once that's done, we can go to OK, and that's going to create this graph for us that represents the results. We probably just want to modify this a bit to make it a bit more attractive. So we can double click on it to open the chart editor, then we can double click on the bars to open this properties window, and then we can use this bar options to make these bars a bit narrower by moving this thing across to the left. We can also go to the fill and border tab and then choose a different color for the bars if we like. So I've chosen a gray. I'm going to go to apply, and we can also just modify anything we like within this graph really. So rather than just having the word median here, if we click on this once and then again, we can modify what this says to make it a bit more specific. So maybe you can replace that with appetite. And we can change the size of things as well. So this is currently a bit small. So if I click on this, if I double click on it, that opens the properties window. I can make this a bit bigger so it's easier to read. And I would probably use the same font that I'm using within my report. So I'm going to choose Times New Roman, then I'll go to apply. So any changes you make within this chart editor are saved automatically. So when you're ready, just click this red button and any changes that you made will be updated within this output file. So that's essentially it. If you have any questions, let me know in the comments and I will try to get back to you. Thanks a lot for watching. See you next time.